This is Excel Lesson 70 from the 4th grade, and we're going to be learning about measuring angles today. And we're also going to learn about the sum of the angles for a triangle and a rectangle. But first, I do have a little joke here for you. It's a riddle, and the riddle is, it's kind of a math riddle here. How much dirt is there in a hole that measures 2 feet by 3 feet by 4 feet? 2 feet by 3 feet by 4 feet. You could kind of work on that if you want to when you're done doing some of the practice problems and you're waiting, like in between. So hopefully you can get the answer to that before the end of the video. So here we go with measuring angles. Alrighty, when two lines cross, an angle is formed. And you can see this line here crosses this line here. And angles are measured in degrees using a protractor. This is a protractor right here. The two lines shown on the right are perpendicular. When two lines cross, or they would cross, like this line and this line, and form right angles, or 90-degree angles, we call those two lines perpendicular. And so here this line is perpendicular to this line because we have 4 right angles there, okay? And any two lines, if they cross, they're going to form 4 angles. So that line and that line forms an angle there, an angle in there, an angle there, and an angle in there. All right, so the question that we have for you right now, what do you think the sum of the angles of a rectangle? What do you think is the sum of the angles of a rectangle? So let's analyze this first before you try to answer it. Sum, do you know what a sum is? You should know that by now. And the sum of the angles of a rectangle. So let's take a look at a rectangle. Here's a rectangle. So we're going to add up the angles of this rectangle. And if you know what the definition of a rectangle is, which is really hard for some of you guys because it's just one of those tricky concepts, a rectangle has 4 right angles, 4 right angles. So what is the sum of those angles in a rectangle? Pause the video. Why don't you show how you got the answer on that line as well as the answer itself. All right, turn it back on when you're ready for the solution. So in a rectangle, we have 4 right angles. That's why it's a rectangle in the first place. And each one of those measures 90 degrees. So you could have done 90 times 4, or if you prefer to add, you could do 90 plus 90 plus 90 plus 90. But I'd like to do 90 times 4, and that's 9 times 4 is 36, and we just stick a 0 on the end, so it's 360 degrees. You have to put that little degree sign there. Then they teach you here that the sum of the angles of a triangle is always 180 degrees. Well, let's take a look at why that would be. How about if I draw a square? Pay attention now, keep watching, look closely. It's not a very good square, but there's a square. And we know that this has 4 right angles, and so that each one of these angles measures 90 degrees, right? Well, how about if I split this right in half diagonally? I draw a diagonal. Now what I have is a triangle here, there's a triangle, and a triangle here. What is the sum of the angles in that? Well, we know that this angle in the corner is 90 degrees. And when I drew this line down the middle of the diagonal, I split that angle in half. So that used to be 90 degrees, but the little part right here that's in this triangle, that little part there is 45 degrees because it's half of the 90 degrees, right? And then we have another one of those angles over here in the triangle that measures 45 degrees. And if I add up 45, 45, and 90, I get 180 because 45 plus 45 is 90. 90 plus 90 is 180. So that shows you why that triangle measures 180. Why do all triangles measure 180 degrees? Well, it works like this. Let's see if you can understand this. I'm going to draw a picture of that triangle. This triangle right here is drawn down here. Now, if I kind of slide the triangle, let's say I get up here and I stand on top of this and I'm kind of heavy and I'm pushing down on it, as that triangle maybe moves and shifts over and kind of becomes like this or whatever, the sides would obviously have to stretch a little bit. each one of those angles in the corner is going to move the same amount and become either bigger or smaller. So this angle down here is just going to kind of tweak a little bit, and this one up here in this corner is going to get a little bit wider than it used to be, and then this, or measure more degrees, and then this angle right here is going to become that angle right there, and it's going to get a little bit more narrow or a little bit smaller. So it's a little hard to explain to you on a video, but hopefully you can see that as you adjust this triangle that has a 45, a 45, and a 90, the angles will all change the same amount. Every degree that you add to one corner is going to be taken off of another corner. It's going to all balance out. So anyway, we'll maybe take a look at that at some later lesson. All right, remember that a line continues in both directions without end. The following notation is used. So this is line AB. Notice that there's a line symbol up there, or we can call it line BA. You cannot just write BA or AB because that doesn't tell us anything. That's just 2 points. That's point A and point B, but it doesn't talk about the line in between, so you have to put this symbol on top of these to make it actually line AB. A line segment has 2 endpoints. The following notation is used. Notice the difference between this one and this one right here. Keep paying attention now. Okay, so we've got that symbol, which looks like this one because it's got the arrows on the end. Lines, remember, go forever in both directions in math. And then this is a line segment, which is a little chunk like that piece out of that line. And so they changed the symbol that's on the top to show that it's a segment. A ray is a line with only one endpoint. The following notation is used. So we start here. It does not go forever in that direction, but it does go forever in that direction. And so you can see the symbol up there on the top. Notice it says ray AB, and the arrow is pointing towards the B because that's the direction it goes in. And then on this one, it's pointing back the other way because the B is the letter where it just keeps going past that B. On the right, 2 rays, AB and AC, have the same endpoint and therefore form an angle. So here we have ray AB, and here we have ray AC. It is called a vertex. Oh, the angle is called a vertex. That right there, that corner, is called a vertex or an angle. AB and AC are the sides of the angle. And they've got the little ray signs up on the top right there. So this is the side of the angle, and this is the other side of the angle. The arrow, small arrow, indicates the angle that is being measured. The following notation can be used to refer to this angle. We can call this angle A because that's the name of the vertex. We can call it angle BAC. Notice we start here, BAC. Or we can call it angle CAB, starting over here, CAB. We cannot call it angle ABC. Angle ABC. Do you know why? Pause the video and think about that or talk about it. Okay, what you should have thought about or told someone is that ABC is not the name of the angle because that would start here, go to B, and then down to C. And we're not talking about the angle that's up here. We're talking about the angle that's down here by letter A. So A has to be in the middle. Okay, it says measure each of these angles with a protractor. If you don't have a protractor right now, as soon as we're done talking about this, you're going to need to grab a protractor and try to measure these angles. Now let's take a look at the protractor. In fact, go ahead and pause the video right now and make sure you have a protractor and take a look at the protractor with me, okay? So here I have a drawing that I made of a beautiful protractor. Isn't it gorgeous? It looks something like the protractor that you're holding in your hand right now. I need to teach you a few things about it. And let me warn you, using protractors is one of the very hardest things that you can possibly do as a kid. I mean, this is so hard for people, so really pay close attention. What you have to do is take the protractor and put it over the top of the angle so that the vertex of the angle goes right inside this hole, that hole right there on your protractor. The corner, the vertex of the angle has to fit perfectly in that hole. The angle itself has to be over towards the protractor. I've seen kids use their protractor like this, and then the angle is pointing over this way. You can't have the angle over this way if the protractor is over this way. the angle is going to be somewhere over in here, right? Pointing towards the protractor. The inside of the angle has to come in here somewhere when you put your protractor on top of the angle. What you have to do is you have to line up one arm of the angle, one side of the angle perfectly with one of these dashes, and I'm going to choose this dash right here this time. By the way, ignore all this stuff down here. This is a ruler. They put a ruler on a protractor, so that's completely different. So you've got this line here that's one of the sides of the angle, and it has to go perfectly on that little dash down there, and the vertex has to go perfectly in the hole. Once you get that, and you'll have to go back and forth with your eyes looking here and looking here with your eyes, then you are going to look and see where the other line goes to on the protractor, the other side of the angle. So notice how my angle is in here. It's not pointing down here somewhere away from my protractor. And then once I find where the line goes up there, I have two sets of numbers to choose from. I have the numbers down here that are like big, 110, 120, 130, and I got the numbers that are smaller up here like 50, 60, 70, 80. I have to decide which of those numbers do I use. I cannot tell you how many hundreds and hundreds of times kids choose the wrong set of numbers to use when they measure their angle. And that's the whole point of doing this, is to measure the angle and get it right. Let's think about which set we're going to use. There's two reasons why we should know this. Number one, an angle that looks like that is a right angle, and it measures 90 degrees. Anything smaller or more closed than that is going to be less, let's try that again. It's going to be less than 90. Anything more open than that, or bigger than the 90 degrees, has to be bigger than 90. It's going to be higher than 90. So this angle right here that we're looking at, that we're measuring with the protractor, first thing you can ask is that angle more open or closed than a right angle or a 90-degree angle? Well, it's more closed than a right angle. It's smaller than a right angle. And so we know that the answer has to be smaller than 90. Okay, if you choose this number right here, just because you're in a hurry or you're not thinking about it, you're going to pick a number 110 or 120 or whatever, and that's bigger than 90. You can't pick that. The line comes right here, kind of between the 60 and the 70, and so we would know that the measurement is going to be 65 degrees approximately on the measure of that angle. And that makes sense, because if it comes all the way up to here, it's going to be 90 degrees, and this is more closed. Now let's say when I line this up here, that the other arm comes way over there. Well, this angle here that I'm going over is going to be more open than a 90-degree angle, so you are going to use the numbers that are bigger than 90. In that case, it's going to be like between, say, 130 and 120, which is 125 degrees. The other way you can measure your angle, this is becoming kind of a mess, but the other way you can measure your angle is by lining up the vertex. Always has to go in that hole, but put the one side of the angle over here, touching that dash on that side. Then you look up here to see where the other line goes and measure it accordingly. And you can always tell based on, is it bigger or smaller than 90 degrees. Now there is one other way to tell. When you have this line here, the angle is starting here and working its way around that way. Let's take a look at these two sets of numbers. Is it going to start at 170 and then go to 160 and then 150? I don't think so. It's going to start at 10, 20, 30, 40, 50. So you know that you're using these numbers. Whereas if you start on this side over here, you're using these numbers because it goes 10, 20, 30, 40, 50 as it goes up. It's not going to start on 170. Alrighty, so hopefully that helps you to learn to use a protractor. It's going to be tricky. So this first angle right here that's measured on your paper for you measures 45 degrees. If it went straight up like that, from here to there, that would be a 90-degree angle. If you put your protractor, which I'd like you to do right on top of that, you should see that in the hole, and then this line here should be aimed right at the little dash out there in your protractor. So your protractor should be going around this way on your angle. And then you'll look and see where this is pointing, and you'll see the 40 right here, excuse me, and the 50 right there, and it goes right in between them to 45. Okay, let's try number 2 together. Take your protractor, and you might have to pause the video as you get stuck on this. Take your protractor and put the circle so it's right around that dot right there, the little hole in your protractor. Okay, then this line here needs to be perfectly lined up with, there's a dash out there on your protractor. So your protractor should look like this on the page, okay? It's probably bigger than that though. And then this is going to be 0 degrees right there, 0 degrees. Okay, now we're going to be going around this way, so we're starting with a number over here, 10, 20, 30, 40, 50, and then it comes up to 90, and it's going higher than 90, and then I want you to see where does this line go over there. It should be somewhere in the range of about 100 and 120, 130, somewhere in there. All right. And if you line it up perfectly, you should see that it measures 130 degrees. All right, so now what I want you to do is pause the video, try number 3 on your own, and then turn it back on after you've measured that. Okay, so you should have measured this angle. You should have put this right on the inside the hole of the protractor, and then this line right here should be pointed at the little dash way over on the side. Now, it's not nearly long enough to reach all the way over there. And then you look up, and this is a small angle, so it's going to have a small number. And that one right there should be pointed right at about the 20 degrees. Now, if you got 19 or 18 or 21 or 22, you're doing great. If you got an answer of 160, you don't get it. You are using the wrong set of numbers. That's a small angle. It's not going to have a big number for an answer. All right, it's next one. We've got 3 problems to do, 4, 5, and 6. I want you to measure all 3 of those with your protractor, and then I want you to turn the video back on once you've done that. Okay, so here we go. You should have already measured these. This first angle goes all the way across, and so that is a 180 degree angle. And then this next angle you should have measured by putting your, you didn't even have to measure that first one. Protractor with the hole looking right at that dot, this pointing right over at the 0 line, and then the answer for that one would be, let's see, this one's going out right between the 30 and the 40. So you should have gotten an answer of about 35 degrees. If you put 34, 33, 36, 37, you're doing great. If you did 150 or something close to that, or 155 or 145 or something, you are not getting it at all. You're using the wrong set of numbers. All right, and then this last one, same thing here. Put the hole right there. This should be pointing right over at the 0. Now this is a big angle. You got to go all the way over and use the high numbers because this is more than 90 degrees. And you should have gotten an answer that's really close to 160 degrees. All right, for these next ones, 7, 8, and 9, you're just going to guess at what you think the measurement is and circle the correct answer for each one. Pause the video, turn it back on when you're ready for the answers. All right, so for this first one, 90 degrees would be right there, so this is bigger than 90 degrees. You would not pick 47, so now you have to pick between these two. Well, 94 would be like barely past the 90 if you look on your protractor, so that wouldn't be it. It would be 141. This next one is a little bit less than 90 degrees. 90 degrees is right there, and it's just barely before the 90 degrees. More closed. 38's quite a bit before. That's more than 90, so it has to be 85. And on this one, the 90 degree angle would go right here. This is, a little bit more than 90, but this one's below 90. It can't be like that. It can't be that one. That one's lower than 90, so it has to be that answer. All right, we've got some division problems for you to try that have remainders. We've got the lines already on there for you. Go ahead and do 10 through 15s or in the video back on when you're ready for the solution. All right, so here are the answers. Fix your answers, and if you have any of them, there they are. And you probably want to know the answer to today's riddle. And the question was, how much dirt is there in a hole that measures 2 feet by 3 feet by 4 feet? And the answer is there is no dirt in the hole because it's a hole. It doesn't have dirt in it. It's empty. It's a hole.